In homework 5.4, we're finding the area between two curves. And let's just make sure we understand how this works. The basic idea is if we have f of x and another curve g of x, the way we find the area between them is we first find the intersection point, whatever that x is, find the intersection point where we stop caring about the area. And what we do is we just take, it's the integral of the top one, whatever the top one is, so in this case that's f of x, minus the bottom one, g of x, from x1 to x2. And the reason this works is because the area of f of x is this whole red area here. All of this is the area of f of x. And if we subtract the area of g of x, which is this really dark red here, what we end up with is the area that was in between f of x and g of x. So that's the idea here. So this first one is probably one of the hardest ones. Let's make sure we know what's going on here. It is, we've got this f of x that is 2x times x minus 1, g of x, which is 3 times x minus 1 times square root of x, and we want to find the area between them. So we have the intersection points because it tells it to us, 0 and 1. If you wanted to check, you could check and see that when x is 0, f of x is 0. When x is 0, g of x is 0. So they have the same y value. When f of x is 1, g of x is 0. And when f of x is 1, f of x is also 0. So they have the same points. So it's the integral from 0 to 1 of the top one minus the bottom one, which is the integral from 0 to 1 of 2x times 1 minus x minus 3 times x minus 1 times square root of x. Now, there's no product rule. We can't do integrals with products, and so this needs to be, we need to use some integration techniques. Maybe you think u substitution. Maybe this is the inside function. The derivative of 1 minus x would be negative 1, which isn't this. So it's better to just multiply it out first. It's the integral from 0 to 1 of 2x minus 2x squared. Here, same deal. It's not use substitution because we don't have the derivative of the inside anywhere. So we multiply out the square root of x. That's x to the 1/2. So when you multiply it, it's x to the 1 plus 1/2 is 3/2 minus x to the 1/2. And we can multiply out that 3. Integral from, I guess I should write it over here where I have some room. Integral from 0 to 1 of 2x minus 2x squared minus 3x to the 3/2 minus 3 plus 3x to the 1/2. The negative distributes and makes it become a positive. So we do the antiderivative. So it's x squared minus 2/3 x cubed. This becomes x to the 5/2, and we divide by 5/2, which is multiplying by the reciprocal. So minus 6/5. The 2 multiplies times the 3. The 5 is in the denominator. Plus, here the power goes up to 3/2. We divide by 3/2, which is multiplying by 2/3, and that's just 2. And we evaluate this from 0 to 1. And the nice thing is 1 to any power is just 1, and 0 to any power is just 0. So what this is 1. 1 squared is 1. 1 cubed is 1, so it's 1 minus 2/3 times 1. 1 to the 5/2 is 1, so plus 6/5 plus 2 minus, when you plug in 0, it's 0, 0, 0, 0. So it's just minus 0. So this is the, if you wanted to, if this was a Fourier response problem, you would just like leave it like this. I would not recommend you try to simplify this. You'd just be like, hey, here's my answer. Here's the area. Right? And you just say that's what it is. But since this is a homework problem, we have a little bit more time. We can be a little bit more flexible. The common denominator we need to get to combine these is 15ths. And I can add this 2 and this 1. That's 3. So let's do some middle school math here. Let's make sure our middle school math is good. It's going to be 15ths. So we have 3. That's the 1 plus the 2. In 15ths is 45 15ths. The way you can do that is you have 3 over 1, you multiply by 15 over 15, 45 fifteenths. This one, to get to fifteenths, we multiply by 5 over 5, so it's minus 10 fifteenths. And this one we multiply by 3 over 3, so plus 18 fifteenths. And so the simplified answer is 3553 fifteenths. That is our area. Great. One more. We'll do one calculator one. Let's see. Let's do number 3. R is the region in the first and second quadrants. So it's going to be like here and here. That's the first and second quadrants. 1, 2, 3, 4. Bounded above by the graph of y equals 1 plus x squared and below by the horizontal line y equals 2. So this is when we really just want to graph it. We're going to be graphing y equals, it's a calculator problem, so we just do it. Y equals 20 divided by 1 plus x squared. And the other line that we're supposed to be using is y equals 2. So we're going to use that also. And when we graph them, it's the area in the first and second quadrants bounded by these lines. I'm going to zoom out a little bit so we can see what's going on up there. So I'm going to change my window so it goes up to 25 as my y max. And now we can see there's this like nice piece of area. And the only thing we need to do is find these intersections. So we press second, calc, intersect, enter, enter, enter. And it tells us one of the intersections is when x equals 3. Enter, enter. You have to move it over so the guess is closer to this one. Enter. The other intersection is x equals negative 3. So, because the intersections, we want to write this down, intersection, this can't just come out of nowhere, at x equals 3 and x equals negative 3. Because of those intersections, this is the integral from negative 3 to 3 of the top one, which is 20 over 1 plus x squared, minus the bottom one, which is 2. That is our integral, and so we just type it in the calculator. You can actually type it in on this screen too, but I'm gonna go back to the main screen to make sure we know how to do it. It's math integral from negative 3 to 3, so we had to find that from the intersections. And you don't actually have to retype in the equations because they're already in y equals. And if they're already in y equals, you could actually, there's a cool shortcut that stops you from having to type it in again, where you go to variables, which is vars, it's right next to the clear button, and you go to y variables, and you type in y1 minus y2. Oh, you guys can't see this. I apologize. The way we get to it is we press variables, y variables, function, and you choose y1 and y2. And what it's literally doing is it's saying, hey, here's y1, here's y2, y1 minus y2. So this is our integral. Just to show you, we could have also done the integral from negative 3 to 3 and retyped it all again. But it adds in chances for errors. Just like there, I put a 1 instead of a 20. This trick will become more important when we get to volumes because the functions get really complicated and you mess it up a lot if you don't do that. So this is the same thing. Notice y1 was already in y1, y2 was already in y2, and again the way we get to it is you press variables, go to y variables function, and just choose the y value you want, and it'll link to the y equals whatever you put in y equals. All right, so this we need to write it to 3 decimal places. It was 37.962. That's if we round the 8 up. 8 rounds to 2. Or in the AP exam on the free response, you can also just concatenate the rest of it. So the 8 rounded up, or you can just be like, oh, nope, we're just not going to write the 8. Both of these are completely acceptable for the AP exam. Hopefully that helps. I don't think the rest of it, there's anything particularly more difficult than that. Again, the general idea is you find the intersections and do the integral from where you need it to be to where you need it to be. Good luck on the rest of your homework.